Today we're doing lesson 22 in module 2. The objective for today was to divide 3 and 4 digit dividends by 2-digit divisors, resulting in 2 and 3-digit quotients. Reasoning about the decomposition of successive remainders in each place value. The difference between lesson 22 and lesson 21 is we're now doing 3 and 4 digit dividends. We're still doing 2-digit divisors, that's the same, but now we're getting results of 2 and 3-digit quotients. So before we were doing, say, 46 divided by 22, and that was equaling 2 remainder 2. Oh, that's a 1. 2 remainder 2. Well, now we're doing, say, 465 divided by 22. That would give us a quotient of 22 remainder 3. So now we have a 2-digit quotient compared to the 1-digit quotient. We're still going to have remainders. Those are still going to be around. But again, we're possibly going to have 2-digit or 3-digit quotients. So that is the biggest difference in between lesson 21 and 22. So let's look at some of the homework. Again, we're still doing the divide and checking. So checking again is divisor times quotient plus remainder. Whoops. Into the next slide. Remainder. So we're still able to check that. This one right here, the divisor was 21. Quotient was 23. Remainder was 4. 21 times 23. 3, 6, 0, 2, and then 2 times 2 is 4. 483 plus 4 equals 487. Does our answer equal the dividend, which is over here, 487? It does. So that is how we check our work. We still need to make sure we're checking our work. I'm starting to see students not checking the work and coming up to me and asking if that answer is correct. Again, we have to check our work. So let's try. I'm going to do C. So the answer to B is going to be, let's see, 32 remainder 5. All right, so let's see C. C is going to be 700 divided by 21. 7 can't be divided by 21. 70 can be divided by 21. So let's see. I'm going to say 21 rounds to 20. So we're going to say 20. So what multiple is 20 is close to 70? Well, I know 60 is close to 70, so that would be times 3. So 20 times 3 equals 60. So let's try 21 times 3. 3 times 1 is 3. 3 times 2 is 6. We have 63. Can we go more? Well, let's try. Let's see if we can go one more. Oh, we cannot go one more, so let's stay at 3 times. 3 times 21, 63. Then let's go ahead and subtract. That's our next step. So we get 70 again. Of course, this is just like the problem set. We had double digits that were the same every single time. So we already know that 63 is the highest we can go. So we're just going to do 3 again. So we get a 63, 70 minus 63, which is 7. So we get a remainder of 7. I'm going to clear up this space over here. Let's check our work. So now we have 21 times 33 plus 7. 33 times 21. And a big reason I like them to check their work is because we need to remember how to multiply double-digit numbers and even triple by double-digit numbers. So 1 times 3, 3, 3, 0. Sorry about that. 2 times 3 is 6. Something already looks off here. Let me check. So 0, we have 3, 9, oh, it's all right. Then we add our 7 in. So we get 700. And that is what we started with. That is our dividend. All right, so we got 33 remainder 7. All right, D I would like them to do, which is 12 remainder 27. Let's go to the next slide. All right, I'm not going to do E. I want them to do E, but I will do F. F seems to be probably one of the harder ones to do. So F states 908 divided by 56 to 908. Can 9 be divided by 56? Nope. Can 90 be divided by 56? Yes. Can we do it twice? Well, if I rounded 56 to 50, I know twice would be 100. I already know 100 is going to be bigger than 90. So I'm just going to stick with 1. So 56, 90 minus 56. All right. Let's make sure we subtract correctly. We have to regroup and unbundle. I have to borrow from the hundreds place. So we're going to change that to 8 to 10. So we get 34. Well, now we need to bring down the 8. That's the new step. We are bringing down now. That's something we didn't really do before today. So let's bring down. We have 348. This is one of the numbers that the students are like, I'm getting confused now, because they'll try to skip count to 348. And I saw it today, so they would skip count. They would get 112, 100, let's see, 68. And then they would get to something like this, and they might think, well, they're just going to throw in, they'll try to add it, but they'll get confused while adding it. So they'll say, okay, 56 plus 168, 6 plus 8 is, 14, carry the 1. Or they'll forget their 1, and then they'll add up just, 6 plus 5 and get 214. But they need to slow down. They'll also start, one problem I'm also seeing is that they'll start at 112, add 56, and they'll add it and add it and add it. But they don't take into account that to get 112, we had to add 56 to 56. So when they're thinking of their multiple, they'll short themselves by 2. So we already have 2 56s here. They'll short themselves by 2, and they'll say, oh, it was only 3 times. When in reality, it should have been 5 times. So I'm going to go ahead. Again, I like to do the rounding method. I think it's a lot faster and more efficient. So 56, I'm going to change to 60. And now how many times does 60, how can I get close to 348 with a multiple of 60? So 56 rounded to 60. Well, if I know my 6s, I know times 5, we get 30. 5 times 6 is 30. So I know 5 times 60 is going to be 300. So I'm going to try 5. 56 times 5. 5 times 6 is 30, 0, 3. 5 times 5, 15, 180. Got 180. Nope, I would not get 180. Again, that's one of my problems. For some reason lately, I've been looking at the number on top when multiplying. I'm doing it too fast. Good thing I checked my work. So 5 times 6 is 30. 0 carry the 3. 5 times 5 is 25. So let's put the 280. We got 280. But is that close enough? I feel like I can add another 56 in here. I truly do. It's 348. I feel like maybe we can get another 56. So let's add a 56 in here. So we get 6, 3, carry the 1. Now I got 336. What I also need the kids to remember is that you're going to add this 56 to this to get, we're at 6 times now. I think 336 is close enough. So let's try 336. 8 minus 6 is 2, 1, 0. So I got a remainder of 12. Now, is this right? Well, right now it's not right because I don't have my quotient fully written. Again, another thing I'm seeing students do is they're forgetting to put their multiple, their factor of how they got 56 to 336 in their quotient. So they might give me a number, 1 remainder 12. Well, I can see they did all the work right, but the quotient isn't fully complete. And that's something we're working on as well. Just making sure we check all of our tiny details because those tiny details are the ones that are getting us. So we get 16 remainder 12. My remainder 12 looks the same. It looks like remainder 12. Let me fix that. There we go. Let me erase all this so I can prove my work. Make sure I did this completely right. So I have my divisor, I have my quotient. So 56 times 16 plus 12. 56 times 16. 6 times 6, 36. 6 times 5, 30. So 336 plus, got to put that place value holder, 6, 5. So we got 896. Well, 896 plus 12. 8, 0, carry the 1. 908. So when students are like, we're just doing division, I like just showing right here, division uses all 4 operations. So we're dividing. After we divide, whenever we're doing our long division, we multiply. And then we subtract. And then to check our work, we add. So it's a good way to help students fluently remember how to do their other operations because we're testing it so much and we're checking and checking and checking. So if we get this checking part in, we're still working on our multiplication, which will come back up throughout the year. So we always want them working on as many operations as possible, especially in 5th grade, to make sure they can multiply, add, divide, and subtract, and not just one at a time, but knowing, a problem might use all 4 operations. So it's a good thing for the students to keep reviewing and learning and fluently working on. So let's look at our word problem. When dividing 878 by 31, a student finds a quotient of 28 with a remainder of 11. Check the student's work and use the check to find the error in the solution. All right, so this is a multi-step one. It's saying that there is an error in the solution. Now, we do remember how to check our work. So it gives us our divisor, it gives us our quotient, but it's saying that we're not going to get the correct dividend. So by doing this, we have to be able to find what the correct dividend is. So let's see if we can knock this one out. It says explanations may vary. So I want to see what kind of explanations I see tomorrow. All right. Well, let's look at 3. A baker was going to arrange 432 desserts into rows of 28. Let's make sure we work on that vocabulary term right there, rows. I like the students to understand what a column and a row is. The baker divides 432 by 28 and gets a quotient of 15 with remainder 12. Explain what the quotient and remainder represent. Okay. So this is a simple one. They don't even really have to do math. It just wants you to explain what the quotient and remainder represent. Well, the quotient, 15, represents how many rows. Sorry, my hand got caught on the thing. Sometimes it picks up the pen I'm using, and sometimes it picks up my hand. 15 represents how many rows. The remainder, 12, represents how many he has left over. How many desserts he has left over. So that was really easy. They really don't have to do math there. Now some of the students might try to do the math, but let's see if they can do this without doing the math. Now, that's all for today. I hope you guys have a good night. See you tomorrow.